This is your reality check.
Welcome to The Reality Check, the weekly Canadian show that explores a wide range of controversies and curiosities using science and critical thinking. Today is June 29th, and it's just me, producer Pat. If you've been listening for the last couple of weeks, you know that the crew is on a break while Darren is traveling. He's currently in Italy, I believe. Today we have an interview that he and Adam recorded earlier this month. It's with Jason, the Germ Guy, Tetro. Jason is a researcher in microbiology and immunology. He's also a best-selling author and a podcaster. Before that, though, I wanted to say a word about our interview with Dr. Stuart Pheromone from 2 weeks ago. On behalf of Stuart, I wanted to thank those checkers who took the time to write us about that episode and to wish him well. Know that I've shared all of it with him, and he's told me that your kind words have been genuinely helpful. And with that said, I hope you enjoyed Darren and Adam's chat with Jason Tetro.
Hi, Jason. Thanks for coming on the show.
It's a pleasure to be with you.
Fellow podcaster extraordinaire. So we're having Jason on because he knows a lot about germs, and he has a great podcast, The Super Awesome Science Show. I want to talk about germs and the podcast, so maybe we'll talk about germs first, and then we'll talk to you about your podcast.
Alrighty, sounds good.
So, as you become known as the Germ Guy, where did this come from?
Actually, not too far from where you currently are. I used to live in Ottawa, and around 2007, 2008, I was making a relationship with CTV Ottawa, CGOH. And in 2008, I ended up doing the news at noon on a semi-regular basis where I would be talking about germs and then taking calls from the public. Well, at the time, I was at the University of Ottawa, and so my official introduction was like, University of Ottawa, microbiologist, Jason Tetro, blah, blah, blah. And one day, the host, Leanne Cusack, simply said to me, we want to come up with something catchier. I'm like, okay, sure, no problem at all. So we wait, we go on live. She goes, and here we are with our usual guest, the Germ Guy. And I turned to her and I'm like, the what? And it stuck.
And she's like, catchier. Like germs.
I know. It was crazy. So I'm in Billings Bridge like a couple of hours later just grabbing some groceries, and there's someone down the aisle going, hey, Germ Guy. And I'm just like, okay, fine. I'm the Germ Guy. And I have been ever since.
I guess it's better than Germy Guy.
Well, I mean, it's funny because some people kind of go with, Germy or Bug Boy or anything. But my favorite is the fact that people call me Jeremy. And I don't know why that happens to be. But then again, I mean, my name is Jason Tetro, and I've actually had some people call me Jethro. So I'm kind of used to it now.
Jason, Germ, GIF, JIF, all these things blend together.
Oh, I know.
Now, would you prefer Microbe Man? Is that a different one that's possible?
Well, I had hoped for like Microbial Maven or something along those lines, but once it stuck, and I couldn't change it. However, in French, I did have an opportunity to call myself Monsieur Microbe, which was kind of cool because then that went all over Quebec, and I got all sorts of really fun attention for like being called, Mr. Germs. And then, of course, The Simpsons got jokingly thrown into that, and before you know it, they wanted to see Monsieur Microbe and Mr. Plow together. But
there you go.
That's digressing.
Excellent. That's a good origin story. Every hero needs one.
Yeah.
So listeners to the show know that I like to start with some basics. We're all on the same page. So before we talk about germs, can you tell us, what are germs?
Yeah, so they're microscopic organisms that normally we can't see with the naked eye. I'll get into why normally in a minute. And the thing is that these are the most populous types of creatures on the planet. There are something like nonillions of them, and that's kind of like a 10 with like 30 zeros behind it. So there's lots and lots and lots of them. The other thing is that there are the most diverse type of organisms that exist. So, we're mammals, and that's great. But depending on whether you're looking at bacteria or viruses or fungi or parasites, amoeba, that type of thing. Of course, there are also worms, which we call helminths or nematodes. Essentially, they are broken up into all sorts of hundreds and possibly even thousands if you go far enough into it, different species. So really, when we talk about germs, we're talking about a huge conglomerate of different type of microorganisms. And the thing is that the idea of germs is really just a term that was used many, many years ago, back in the 1800s. But really, it was more along the lines of trying to give the public something that they could work with. And one of the things I find so funny is germs seem to have a much better public impact than microorganisms, such that in 1912, when it was declared a war on germs, that it became this big headline that you could see. And so the lead everywhere was, "We have the war on germs." But if you had left it as microbes or microorganisms, we probably would never have seen that lead. And we might actually be in a better place when it comes to how, we get along with them.
Because certainly germs have a negative connotation, and it's hard for me to see that as positive in any way, while microorganism seems neutral as a term.
Exactly. And I think that's one of the problems that we have. And this is something that I wrote in my first book, The Germ Code. I wrote it kind of like a Woody Allen movie, sort of a dysfunctional relationship. And one of the places where I started was, why the heck did we call it a war? Did nobody read Sun Tzu? Come on.
The Germans that we fought against? Maybe that's it.
That happened with the Weimar falling a little bit later on.
A little bit later, eh? Yeah, that's true. 1912 was a bit early.
Yep. Yeah.
So you said they're microorganisms, but what sizes are we thinking about, if we can try to picture this, when we talk about germs?
Yeah, again, when you start looking at germs as a whole, you're going to be sort of saying less than a millimeter in size. But then what happens is when you break it down, you're going to be getting into even smaller. So when you're talking about viruses, we're talking about nanometers. So, 1/1000th of a meter. Then when you're talking about bacteria, what you're doing is you're actually talking about micrometer size. So now you're 1,000 times larger than viruses, but you're still 1,000,000 times smaller than a meter. So it's still going to be invisible. However, there have been some really cool discoveries as of late where we've been able to identify bacteria that are almost a millimeter in size. So you can actually see them with your eyes. And I think the largest one out there is called Thiomargarita namembiensis. And the funny thing is that when you hear Thiomargarita, you're thinking sulfur drink? No. Margarita actually stands for pearl. It also means daisy in Spanish. So the fact is that margarita, the drink, is based on the fact that at one time it was actually called a tequila daisy. So, yeah, sometimes you get this weird trivia that goes on when you've learned the origins of these Latin names. So Thiomargarita literally means sulfur pearl. And when you look at them under the microscope, they're these humongous pearls that you can almost see with your own eye. Then you have the fungi. Now, the fungi on their own individual cells, you can't really see them, but then what they do is they build up, and then all of a sudden you start to see them, and they form all sorts of lovely colors when you're walking in Gatineau Park. They have mushrooms, which can be really tasty or poisonous, depending on which one it is. Make sure you read those charts, kids. And then, of course, there's the largest organism on Earth, which happens to be a fungus, because it is essentially a connected network of fungal cells which span all over massive forests. And so when we talk about the size of germs, when we talk about the individual ones, we're talking pretty small. But then when we start talking about how they develop into these larger three-dimensional structures, they can actually end up being, as I said, the largest being on the planet.
Okay, so there's a huge range of germs and a huge range of sizes, and that also makes me think there's probably a huge range of effects. So you sometimes hear there are good germs and there are bad germs. Does that make sense? What are people talking about when they say that?
Well, this is, again, another translation that makes it so much easier to understand in the public. There's really no good or bad germs per se. There are different classifications. So the ones that we want to stay away from, the ones that cause us illness, those are called pathogens. And then what happens is you have some of them which really do nothing. And if they happen to interact with your body, we call them commensals, neutrals. Then there are some which seem to have some kind of benefit with our bodies, and we tend to call these symbionts. However, they're not necessarily good unless you happen to play D&D, at which point they are chaotic good. Because basically they do what is needed for themselves first, and then the environment. And then if something happens to be helping you in the process, well, good for you, but that's not really why they're doing it. So the reality is that when you look at these bugs, they're all basically looking out for themselves. And when they get into communities like we see in biofilms or like you see in your intestines, they'll sometimes interact and communicate with each other, things that we call quorum sensing. But for the most part, they're not communicating with you in the hopes of getting you to do something for them, which is funny because what ends up happening is sometimes they will produce byproducts that have an effect on us that make us do certain things or feel certain ways. Now, unlike that Look Who's Talking movie where the baby was basically kicking Kirstie Alley into drinking an entire tub of orange juice, we're not doing that for the bugs, and the bugs are not making us do this for them. It's just a chemical reaction that occurs that leads to the formation of neurotransmitters that affect our brain. It's called the microbiota gut-brain axis, and it's absolutely fascinating when you start getting into that. But when we get back to the original question, no, there's no good or bad germs. They just affect us in different ways.
Well, that makes sense. Things are what they are in terms of how they affect the world and affect us. As I've gotten older, I think I've become a bit more of a germaphobe. I found this just because if a cold really hits me hard. So I have two questions related to that. Public health experts indicate we should cough or sneeze into our elbows. Mm-hmm. So first, I'm wondering if you think that's a good idea. But then I'm thinking of a couple times when I feel like I've been in the wrong place, where someone turns to me because I'm near their elbow, and then I feel I'm getting their cough. And I'm like, if you just sneezed forward into your hands, I would have been spared. Mm-hmm. So I guess that's the first one. And what do you think about that?
Well, first off, this was done, I believe, by Mythbusters, believe it or not. They were checking how far you get the spray of your saliva if you happen to sneeze in your hand, sneeze in your elbow, that type of thing. The elbow is good because it will help to prevent the majority of those droplets from going off into the 6-foot distance that they normally tend to go if you were just sneezing out in the open. However, you are still going to have some leakage, if you want to call it that. And when that leakage occurs, then there is a chance that if you happen to be in a very close proximity, like say, an airport security line, then there's a good chance that if you can't get away, like an airport security line, unless you want to go to secondary, then there's a good likelihood that you will be exposed to those droplets and potentially could come down with an infection. What I like to say is that whether the people are dabbing, whether they're playing vampire, I do not say blah, 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 or just sneezing out in the open because they're natural people, the best thing for you to do is just make sure that you're protected. And the way that I've always recommended is using a scarf. There was a study back down in 2010 where they actually compared different scarf materials with an N95 mask, which is the one that you use. And every time you see something happening on those television shows when there's a biohazard, they're always wearing those masks. And it was anywhere from about 60 to 90% effective, which is probably still more effective than someone sneezing into their elbow improperly. And the funny thing is that you can stop all the leakage from happening if you sneeze into your elbow, but you're going to need a standard operating procedure consisting of about 7 different steps. People are not going to follow SOPs on good days.
Right. Or they just need really large elbows to have a crook there that's going to stop their size of their mouth.
Maybe Andre the Giant, bless his soul, and Shaquille O'Neal, but other than that, I don't know if that'll work.
So second was, how long do germs stay on a surface, like a door handle or a faucet? There's this situation, which I encounter at work because our bathrooms are old, where you have to turn the faucet. So then I see people, they go to the bathroom, they turn the faucet on, they wash their hands, then they turn the faucet off with their hands that they just washed. And I'm like, didn't you just reinfect your hands, especially because it's wet, which I assume makes it more likely for things to transfer? So I tried to use paper towel, and the whole thing seems annoying and ridiculous, but I think that's the best strategy. Is that correct?
Yeah, I mean, if you look at any of the public health posters, they usually recommend that you use that paper towel to turn off the taps, and that's why. When something is wet, there's a very good likelihood that it will transfer to your hands, and if there happens to be bugs in it, then those bugs will probably transfer to your hands. done lots of studies on that when I was at the University of Ottawa, and it's all fascinating and cool and can put you to sleep really quickly. The thing that you need to understand is this. When we talk about survival, what we're doing is we're essentially saying, well, how long can a bug last if we take away all the water, the nutrients, and make the environment hostile for it? Because that's what they need. So if you have water, if you have food, whether it be actual food or whether it be oil and grime and dirt, that type of thing, they're going to survive and you're not going to be able to get rid of it. If you take all of that away, then we start to look at how we can see survival rates happening. And there are these what we call curves, kill curves, if you will, that allow us to sort of visualize how long these bacteria can last. And sometimes it's not a heck of a lot of time. If you were to take something like Helicobacter pylori, which is that stomach illness that causes all sorts of pains in the stomach, can lead to ulcers and even stomach cancer, it only survives in the environment for, at the most, a few hours. If you start looking at bacteria such as the foodborne diseases that we always talk about, like the E. coli, the salmonellas, the campylobacters, you're probably looking at anywhere from 8 to 24 hours. Some of them may last up to 5 days. If you start talking about bacteria that are able to create spores, and this is where that big name that we've all been hearing about lately, Clostridium difficile, C. diff, it can survive months. In fact, we tested it. It can probably survive indefinitely on a surface.
Wow.
And then what happens is it gets under your hands, it gets into your mouth, it gets into your gut, and all of a sudden it's got the water, the nutrients, and the warmth, and boom, off it goes. So that type of thing means that if you are, say, in a healthcare facility where there is the potential, and usually what is the case is there is Clostridium difficile, then any surface that you touch that's been touched by a number of other people potentially could have C. diff on it. So that's one of the reasons why we're very, very cautious about making sure that infection prevention control is more than just simply disinfecting surfaces, because that is important. But I've done the studies in the past, and the fact of the matter is that it remains clean and disinfected until someone touches it. That's why you want to be focusing on keeping your hands clean. And when you're talking about most bacteria, alcohol hand sanitizer is going to work. Same thing for viruses. But when you're talking about things like C. difficile and some of the more hardy viruses like hepatitis A virus and that, you're going to want to make sure that you're just washing your hands. Now, in terms of survival for the viruses, we're usually talking anywhere from 4 to 8 hours to 24 hours. But then there's one that will always end up being sort of the outlier, and I was working with it back in the University of Ottawa. It's called norovirus. Probably heard about it. Mm-hmm. Sends cruise ships back to dock. That thing can survive something like 28 days on the surface. So, yeah.
Well, that's useful, interesting. And now I'm wondering, as a related idea, if you're sharing food with a group of people, should you not do that? And I'm sort of getting at the idea, is your mouth, we'll say, resilient or robust enough in terms of its ability to take on different bacteria or germs compared to, say, accidentally touching your eye with your finger that shared the food with the other people?
Well, anything that has a mucous membrane is probably something you're not going to want to touch with someone else's food or bodily fluids, because that's really what we're talking about. When we talk about sharing food, we literally are talking about sharing bodily fluids. And yes, I get it. There are definitely people who are going to be out there going, oh no, Jason, we share bodily fluids all the time and we're perfectly safe. Yes, that may be the case. We're talking about sharing bodily fluids that potentially could lead to you having an illness. Now, when we talk about this, we normally talk about someplace other than your mouth, or in certain cases, we are possibly talking about that. There was a University of Calgary study that showed that some people had particular types of infections around their genitalia as a result of having, shall we say, mouth contact. And the germs themselves were actually from the mouth. So, sharing bodily fluids, no matter where you're going to be going in terms of mucous membranes, is always going to be an issue. Now, if you're sharing food, like sharing a fork with someone, most of the time it's not going to be a problem. And if that person happens to be sick, you're going to want to not do that. But heck, if that person is sneezing, sputtering, whatever, you're probably not going to share that fork with them in the first place. In your mouth, you have to realize that it's its own ecosystem. So a bacterium, virus, whatever, gets into your mouth. First thing it's going to find is it's going to start getting diluted as a result of the saliva. That in itself potentially is going to help you to stay safe. Now, in that saliva, there are going to be immune molecules. We call them IgA antibodies. And what these do is they seek out potentially bad bugs, wrap onto them so that they can't infect us. And then what's going to happen is even if they get past that and they get into, the cheeks or onto the tongue or onto the teeth, what's going to end up happening is that you've also got bacteria there. You've got something like billions of bacteria in your mouth with could be dozens, if not over 100 different types of species. They're not going to like this new invader, and more likely than not, they're going to kill it. So a single introduction of a foreign bacterium that's coming into your mouth is probably not going to cause a huge problem. However, if it does happen to be one of these viruses like norovirus, or it happens to be one of these low-level infection causers like, a salmonella, enteritis, then there's a good likelihood that you're going to swallow it, it's going to get into your intestines, and then bad things could potentially happen.
Right. Okay, well, we've been mainly focused on, I guess, the negative side of germs, and now I'm thinking I should walk around in a hazmat suit with gloves on and never touch anything or anyone, and never share food, of course. But to what extent is that going to actually make it worse for me? And now I'm thinking of children who perhaps aren't exposed to enough dirt or germs in their growing up. Does that make them more susceptible to getting infections later on?
Yeah, well, you see, when I got into working in the public, one of the things that I did was I got into what we call social marketing. And what that does is it allows you to be able to create messaging and stories to get people to do something you want them to do, which is normally beneficial, like eat better diets or get more exercise, or in this particular case, buy my books. And the reason I say that is
it's all the same goal.
Yep. It always is. And the reason that I say that is because those two books essentially are to help you to get over that germophobia. The first book itself is really about that dysfunctional relationship, like I said, and it helps you to understand that we only have about 1,500 out of those, potentially millions of different species that could potentially cause infection. And so while we tend to focus on those in the media, whether it be the news or whether it be social media or whatever, you're always going to be hearing about the bad ones. That's just the way it works. The books are helping you to understand why we focus on the bad ones so much, but also how we can start focusing on the good ones. And by the end of the first book, you pretty much have an idea that, much like Douglas Adams in Hitchhiker's Guide to the Galaxy, I'm telling you, don't panic.
Because they're mostly
harmless. Because they're mostly harmless. And that towel could be used as a scarf.
The towel will work as a scarf. I have tried it. It works perfectly.
Awesome.
There you go. I wish Ford Prefect had actually said that in the past. But anyway, the second book itself is about how to get along with germs. And I think the best of all reviews I've ever had came from the Washington Post, which called it a dating guide for germs. And what you're doing in this particular case is you're learning how to work with the ones that are commensal, that are symbionts, to be able to make your life better so that you can not only love the microbes, but also find a way to be able to use them to your advantage. Because at the end of the day, what we've been finding ever since about 2007, when we had the Human Microbiome Project start up, is that every single week we're hearing about something new and magical that these microbes are doing to us, such as I said, the microbiota gut-brain axis, that leads to some kind of influence on our lives. And so if we can find a way to become closer to the bugs that are helping us inadvertently, chaotic good, as opposed to getting closer to the ones that are either, not helping us or making us worse, like those pathogens, then we in a way can start improving our lives. Now, we're always going to have to avoid the bad ones. We're always going to have to use what I call tough love on them. But quite honestly, what in life do we not have to use tough love on? I mean, our parents had to do it when we were bratty kids. Our professors do it when they tell us that it's not our best work. Never happened to me, of course. We see it everywhere. So I think the idea of loving microbes is really the same as just loving everything else around you. You just have to understand when there's good, when there's neutral, and when there's bad, and how to avoid it.
I think those are great points, and it certainly aligns with what we try to do in our podcast of trying to challenge misconceptions and realize people have a negativity bias, and of course the negative thing is going to stand up, and we want to sort of snuff out those misconceptions, which is probably why you do your podcast, the Super Awesome Science Show, to try to correct some of those false impressions and to promote interesting scientific ideas.
Yeah. My first lab job came in 1987. I was just going to be starting out. I didn't start really working until 1988, but I walked into a lab at the University of Ottawa. Don Kushner was the professor, and he asked me, "What do you want to do?" I said, "I want to change the world." And he laughed, and he thought it was great. He played his violin. He was really good at that. He showed me his children's books. Fantastic person. And he showed me, you change the world by doing small individual things over a long period of time. You don't just change the world right now in the moment. It's very difficult to do that. So what he instilled in me was this idea that if we can make little differences happen, then we can make a change in the environment. Now, I did this with CTV by going on and doing the news at noon and answering people's questions. I did that with the books. And then when I had the opportunity to do this podcast, the first thing that I wanted to be sure of was that we were going to do something that was a bit different because we wanted the listener to gain something. And even if you listen to the very first promo for the show, you'll hear that it's science that is meaningful to you. And the reality is that science is everywhere. And quite honestly, even though our good friend over on Parliament Hill, Justin Trudeau, got flack for it like nothing else, reality is we are all, in our own ways, scientists. And so what I'm trying to do with this particular show is give people the understanding that science is there, the science is meaningful to them, even if it's things that they don't really think. I mean, we did an episode on barbecue. People would be like, wait a minute, barbecue is science? And it absolutely is. When you have that, all of a sudden the science becomes more and more prevalent in your life, and then you start to see how you are a scientist. Because at the end of the day, what is a scientist? A scientist is someone who takes a hypothesis, what if, then finds a way to test it, methods, materials, all these types of things, sees an outcome, results, figures out whether they like the outcome or not, discussion, and then comes up with a conclusion as to where they're going to go. Are they going to repeat what they've done, or are they going to find something else, a different direction? And really, that's a scientific paper right there. So every single day we're doing what is akin to scientific papers, just on very small level scales. And the more that people understand that, the more likely it is that they'll accept science. And so that's really the goal of this podcast. But we want to do it in such a way that it's not explicit or it's, it's not right in your face. I want you to have this meaningful to you. It's done in a way that it comes to you slowly over time.
I think that's an absolutely excellent framing, and if we can try to cultivate the idea of using science and rigor and evidence-based thinking throughout people's lives, it's fantastic. Yeah. And as you said with your podcast, not only is it very diverse for people listening, it's not just about germs or barbecue, but some recent episodes there's something about quantum theory, another one about artificial intelligence. So it's very, very broad, but it's also very accessible because you have interviews with diverse and interesting guests, as well as some sort of background contextual material that helps the reader understand as you go along.
Yeah, and what I find really interesting is that the nature of the guest is completely irrelevant to having it meaningful to the audience. I'll give you an example. I've had a couple of celebrities, and we're going to have a few more, come on the show, and they show how science matters to them, and that's wonderful. But some of the most loved, the best feedback that we've gotten have come from, believe it or not, trainees graduate students. We had this one graduate student who was at Purdue University, Courtney Beer. She talked about something called social desirability bias. And what it is a tendency to be able to agree with the people around you, even though you may not believe it yourself.
That makes perfect sense to me.
Yeah, exactly. And the thing is that she didn't call it the SDB, I did. What she called it, the Hermione effect. And it's so true, because as much as we all might be dissing Ron all the time, all the books, all the movies, Ron's the bad guy, Hermione, watch her. Every time she's in a group and someone says something, she's just totally agreeing with them. And then she doesn't actually do anything afterwards. It was brilliant.
You got to find a way to reach people, right?
Mm-hmm. Absolutely. And then we had another guest. We were doing the science of beauty. And we had Zaya Tong, who everyone's going to know from Daily Planet. She has a new book out. She's talking about the blind spots and how we miss beauty because we're missing the science. And then we brought on a graduate student from New York University, Anne Brielman. And we got her to tell us about the research that she's doing. She is mixing philosophy and neuroscience to be able to define an equation for beauty. It's just absolutely fascinating. And the most amazing thing is that she's taking people like Immanuel Kant, who created all of these interesting abstract ideas, and she's putting them to the test in actual experiments. And she's come up with a way of being able to measure beauty and how we can appreciate it or not based on our higher level of thinking. Fascinating.
Deontological beauty standards, eh?
Absolutely.
Well, as you just alluded to, you have such a range of interesting people and also have a range of topics. How do you develop your themes? How do you come up with different ideas for your show?
Well, initially it was sitting down with the rest of the team through emails, going back and forth, saying, this would be an interesting idea, what do you think? Because I really was coming from the scientific perspective, and then the other members of the team, Dila Velasquez, who is the story editor, Kelsey Campbell, who is our editing whiz, Rob Johnson, who does the audio, we were all going to sort of have our own little contribution. So I came in from the scientific, Dila would come in from the public, and then Rob would say, okay, well, what about this in terms of music and stuff? And eventually what ended up happening was we came up with a format. Now, this took months. I mean, we came up with the idea at the beginning of 2018. We didn't actually air the first episode till the end of November of 2018. So it took a long time to develop. But as we went along, we started to realize the theme itself is really something that can be appreciated by the public. And then the science fits its way in there. And how to develop the stories, the musical beds can really offer some help. And as that was developing, what we got to realize was it was beginning to create new questions, which ended up becoming new themes. And that's essentially how we got the first 6 months done. Now we're getting questions from the public. The feedback that we're getting is leading to new themes. So some of the ideas that we're coming up with, we just recently released one on artificial intelligence and health. That came from someone who was wondering if we're going to be able to trust a machine instead of a doctor because this person can never find a doctor. We're going to be talking about the idea of being able to get sun and how much sun is too much sun. We're going to talk about Lyme disease. So all of these things sort of are coming from the people who are sending us questions that we're turning into themes that we can then use. And the best part about it is that it's giving us an opportunity to reach out to some really amazing experts so that my contributions as the lead-up man, if you will, become less and less important. So unless we happen to have something where you really need a lot of exposition to get where you are with the guest, my contributions are becoming no more than a couple minutes at a time, and the guest tells the rest of the story.
Mm-hmm. Right. You become a good maestro of sorts as opposed to playing all the instruments.
Exactly. Yeah. Unfortunately, I always wanted to be known as the Dave Grohl of microbiology, but
Maestro Microbe?
Maestro of Microbes. Unfortunately, you're too late because we've got the show now, right? And it's not just about microbes. People have asked me, well, why are you the Germ Guy? And we actually had to have a meeting about this. And I'm now called the Germ Guy, not because of germs as microbes, but because of germs as in like wheat germ or germ layer, germination. I am now the Germ Guy, germinating your minds with science. It's going to catch on one of these days. I know it will.
One of these days. If you say it enough times, desirability will also kick in and people will agree with it.
We're just going to leave that with no comment.
Yes. So on our show, we as you know, cultivate science and critical thinking, and we sometimes make an occasional error, so we try to correct ourselves. I wondered, over the time you've been doing it, is there anything you feel you've been wrong about, or at least felt you had to update your beliefs upon?
So when it comes to the show, we have many levels of checking just to be sure that we know we're accurate and that type of thing. And that's great. Personally, I tend to take risks. I tend to experiment because I have all the theory, and so I can try different experimental designs to see how that's going to work. I've been wrong, and that works. So, I've had to pull articles in the past. I've had to apologize for things that I've said. When we're talking about my own personal beliefs changing, what's really interesting is that it's not that the core tenets or ethos of my belief changes. It's how I adapt myself to better reflect those tenets that change. When I was talking with Courtney about the social desirability bias, what I realized was that sometimes I would just simply agree to do something simply because I thought it was the right thing to do. Now I'm learning how to say no to things. But what has happened is that some of the ways that I thought I could go about improving my own life or being a better person ended up being seen as, oh my goodness, I'm actually getting in my own way. And so when it comes to those ideas, I tend to try and do my best to bury them and then go on to finding those better ways and turning those into my habits as opposed to the ones that may have been stalling me. So yeah, personally in how I view the world and how I view science, the last 6 months have really opened my eyes to a lot of things. And you'll actually see some of that transition if you go through the episodes, because the first few episodes, it was really me as the expert, then talking with other experts. And now it's more about me just having a fun time as that maestro, if you will, and allowing the experts to really teach me as well as all the other people. And even though I may be an expert in something, you're not going to know about it unless you do a PubMed search on me, because I don't want you to know about my expertise. I want you to believe that I am the same level as you are, no matter where you are. Because at the end of the day, that's how we all learn together.
Jason, this has been delightful. Thank you for coming on the podcast. But before we go, if people want to find you, your books, or your podcast, how should they go about that?
So if you want to learn anything about me, you want to go to jasontetro.com. It'll have links to all the stuff that I've done over the last decade or longer now. However, if you'd rather not listen to me anymore and you want to hear about the show, you can just Google the Super Awesome Science Show. We're on all the podcasts, Apple Podcasts, Google Podcasts, Spotify, you name it, we're there. And if you want to find more about notes, then you go to curiouscast.ca. You'll be able to see the Super Awesome Science Show. Usually it's right there on the front page. You click on that, you'll have access to all the episodes as well as all the show notes, which are being hosted by Global News. That's one of the beautiful things about this show, is that when we first started, we really didn't have that much of a presence. But the people at Global really loved what we were doing, and now they're helping us to really expand upon the podcast. So I really have to give a shout out to them, even if they happen to steal a couple of our episodes to do features on their own. I'm not complaining.
Thank you for your time, Jason Tetro.
For show notes or to discuss this episode, visit our Facebook page and website at trcpodcast.com. For general inquiries or to send a topic or parody suggestion, email info@trcpodcast.com. Help support the show by leaving a review on iTunes and liking us on Facebook. Follow us on Twitter at TRC_podcast.
Outtakes.
Pat, you can delete that. Anyway.
Pat loves notes.